Hi Mungi, how are you?
I'm good as well.
I'm good. Thank you very much for joining. We're just gonna work on vertical projectile motion as you requested. But remember, most of the time when you do vertical projectile motion, it has to do with. We don't have much notes on this topic because most of the questions that you do on examples are the ones that you're going to get from your exam. So we're just gonna focus on the exam type questions. You understand?
Yes.
Okay. Uh, how is it going at school?
It's going well. Kind of understand most of my maths topics. It's just the physics side that's giving me problems.
Oh, okay. Can you see my screen?
Yes.
Okay, 100%. Now we can start with the lesson, okay? Uh, Tell me, can you interpret a graph that has to do with vertical projectile motions?
We didn't really start the topic.
Okay, you haven't started with projectile motions.
Yes.
Oh, okay. Don't worry. It's fine. Okay, I'm just gonna give you the formulas that we're going to use on vertical projectile motions. Okay, so let's start with the equations now. Mungi, I'm sorry, just give me a second. We are starting now. Okay, are you still with me?
Yes.
Okay, so you know what I need you to understand. I'm just gonna. What's your curriculum? Do you do CAPS or IEB?
Sorry?
Uh, at school, do you guys do CAPS or IEB?
It's caps.
Oh, it's CAPS. Now I'm just gonna call this VF. So VF is going to denote our final velocity. Now, so if we want to say final velocity, we're going to use the weight VF. So my VF is my final velocity. When I say V initial, this will be my initial velocity. So this is my initial velocity, okay?
Okay.
Right. So when I say displacement, most of the time it's either we can call this delta y or we can call this delta x. This will depend on how is the object moving. Is it up or down? So delta x and delta y, this is your displacement, okay? Right. So now, when I say delta t, I'm referring to the time. So delta t, this one will be the change in time. This is the change in time. Okay, it's also important that we know that one. And then we have A, which will be the acceleration. So these are the symbols that we're going to use in vertical projectile motions. So A will be our acceleration. Right. So based on this, I'm just going to give you the formulas that we're going to use now. But now, I need you to know that if, Mungi, what's wrong on your side? I hear some of noises. What's going on?
It's the neighbors.
Oh, okay. I'm just going to mute you now.
Okay.
Because this distracts me on my side, because I don't know, but I just get like distracted. Now I'm just gonna mute you. Then if you have a question or I want to ask you something, you can just unmute. Ne?
Okay.
Okay. Okay, so let me quickly write down the formulas that we're going to use. But before I write down the formulas, remember, if an object is in free fall, the only force acting on the object is weight. So what I'm trying to say is that, let's say we have an object that is in free fall. Okay, so I have an object is in free fall. Do you know what is free fall?
No.
Oh, okay. So when we say an object is in free fall, there's only one force acting on the object. So we're going to have what? Only one force. There's only one force acting, and that force, we call it what? The weight. So free fall is when something, let's say we just project something downwards, there was no force applied, it started at rest, then we release it, we call it that free fall. Let's say maybe we are in a hot air balloon, we are moving up, and then we just leave something, then it dropped down, that's a free fall. So now, when we say the object is in free fall, the only one force acting on the object is what? Is the weight. Is the weight. So now the object accelerate will be due to only gravitational acceleration, and sometimes this will change. You'll see how this works. Right. So now I'm just gonna give you the equations that we're going to use. I'll only focus on the CAPS equations. I'll only focus on the CAPS equation. Okay, so the first equation that we're going to use, it says Vf, it's equals to V initial plus A delta T. You understand?
Yes.
Okay, I'm going to say the second one, the formula that we're going to use, the second one is delta x, it's equals to V initial delta t plus 1 over 2. I hate writing these things while you have this thing on your formula sheet, but now please just give me a second, everything will make sense because I'm going to explain when to use which formula. The reason I'm writing these formulas down is for me to show you when should you use this formula. Okay, so it's very important that I write them down so I can be able to explain this to you. So the second one is Vf squared, and this is equals to V initial squared plus 2A delta x. We just don't use any formula, it depends on what we are working on. The last one is delta x, it equals to Vf plus V initial, everything divided by 2 delta t. Are you with me on that?
Yes.
Okay, so now the first formula, I'm going to explain when to use the first formula. The first one, I need you to use it if the displacement is not given. So this one, if you don't have a displacement, I need you to use this formula. We use this formula if the displacement not given. So now, if on your question you are not given the displacement, that's the formula to use. So now on this one, so the second one, we're going to use it if the final velocity is not given. Can you see the second one? We don't have the final velocity. We're going to use this one if the final velocity not given. We are running out of time. And then this one, we're going to use it if the time is not given. And then the last one, we're going to use this if we don't have the acceleration. Don't worry, Mungi, this will make sense. Everything will be easy. Just give me a second. Now, so from this, I need to discuss with you the tips that you need to do when we work with vertical projectile motion. The most important thing is to make sure that you draw the diagram. If the diagram is not given, make sure that you draw the diagram. You draw the diagram. If the diagram is not given, you draw the diagram of the situation. Then second, you choose direction, and I always want you to choose positive and use the conventional through each question. Right. So now I'm not going to talk about the graphs of motions because we won't have enough time to talk about the graphs of emotions. But we're just gonna work out on few questions so that you can know how to apply these formulas, so that you can understand how the given formulas you can apply them in an exam. Are you still with me?
Yes.
Oh, okay. So now let's say I have a hot air balloon. I'm just gonna give you a situation here. Let's say we have a hot air balloon, and now this hot air balloon I'm just gonna say, maybe you know what is a hot air balloon, right?
Yes.
Right, it's moving up and I have my ground here. Let's say this is the ground. Right, if this is the ground, and then a hot air balloon is ascending at a constant velocity. Right, so it's ascending at a constant velocity, and the height that it is traveling so far, let's say the h is equals to 92.5 meter. Right, not meter, meters. Okay, right, look at this now. At a height of 92.5 meters, we're going to drop a sandbag. So let's say it is accidentally dislodged. So we're going to drop it down. We're going to drop the sandbag. So this is my sandbag. So the sandbag will be dropped at a height of 92 meters. And the hot air balloon is traveling at a constant velocity. I don't think I'll be able to write the whole statement. So the hot air balloon is traveling at a constant velocity. So now, and then we're going at a height of 9. From this height, it will take the bag, it will take the bag 5 seconds to reach the ground. So it will take the bag 5 seconds to reach the ground. I hope you are with me on that. You still with me? Okay, so now the effect of air resistance, we're not gonna focus on that. Let's calculate number 1. Question 1. Calculate the velocity of the balloon. When we drop the sandbag, when the sandbag is dislodged. So now this is the statement. We need to calculate the velocity of the balloon when the sandbag is dislodged. So now remember, this hot air balloon is moving up at a constant velocity. Right, so what I'm going to do on this problem, I'm just gonna try to analyze what I'm given, then I'm going to write my data down. Okay, I'm going to write my data. I'm just gonna put everything that I have down. So look at this. I'm just gonna say data. Right, the displacement delta, what is this? This will be my delta y. The height is 92.5. We can see that. And what else do we know about the velocity of the ball? We need to first maybe calculate the velocity. We are calculate the velocity of the balloon when the sandbag is dislodged. We need the V initial. So they are asking you to calculate the initial velocity. Okay, so now when they want you to find the initial velocity, what is your acceleration? Acceleration is equals to, I'm going to take up as positive. Which will mean that my acceleration, you see on this equation here, we have this A here. You see that A is equals to 9.8 meters per second squared. So what I'm saying is that the acceleration is 9.8 meters per second squared. That's your acceleration. So when I have the acceleration, but now we said we're going to take up as positive. Acceleration always acts down. It always acts down, which means that this will be negative 9.8 meters per second squared. Then another thing that we have is time, which is delta t. It's equals to, it's given as 5. It's always measured in seconds, okay? Right, so we have delta y, we have a, we have delta t. We need to use the formula that we don't have the v final. We're going to choose the formula that we don't have a v final. So the first formula won't work. The first one, because it has the final velocity, that one won't work. And then even number 3 won't work. Then even number 4 won't work. Can you see that the only formula left is this one? So now what I need you to understand when it comes to vertical projectile motion, choosing the formula that you need to use is very important. So I did show you how we choose the formula. So the formula, for us to choose the correct formula, we check what we are given. So I need you to tell me if you understand how we got to choose the second formula, because the second formula we don't have the final velocity. So I'm just gonna rewrite my formula down there. I'll say my delta x, it's equals to this is equals to v initial multiplied by delta t plus half of a delta t squared. That is the formula. Now we can just substitute. Delta x is fine, we know it's delta y. I'm just gonna, now let's talk about the direction. Another important thing when it comes to projectile motions, this is very, very important, né? Mungi, please listen to this, né? Listen to this. If the direction, what is this? Remember this length here, né? This 9.2, 92.5. It is what? Is the height where the sandbag is released. So now where is this sandbag going? It's going down. So this tells you that your height is acting downwards. So we said we take up as positive and the height is acting downward. Therefore, we need to substitute this as negative 2.5. You see, if you don't understand this one, then you're going to have a problem. I don't want to lie. If you don't understand this part, you're going to have a problem. Mungi, listen. At the height of 92.5 meter, we drop a sandbag. Where is this sandbag going? Down. So this tells you that the height is acting down and we take up as positive. So the height, we need to substitute it as negative 92.5. It's very important for you to understand that part. Very, very important. Because if you don't, we're going to have a very, very big problem. I don't want to lie. Tell me, do you understand what I'm saying here?
Yes.
Okay, it's fine. We'll do more example. The V initial is what we are looking initial. Delta T is given as 5 plus 1 over 2 into acceleration is negative 9.8. And this is into 5. Remember, the 5 is squared. So now you need to do your algebra. Right. So I think I need to give you the notes. Né? I need to send you the notes. So since I'm going to send you the notes, I think it's also important for us to say here that the height, the displacement is negative as up was taken as positive. We take up as positive and this thing is moving down. So this tells you that the displacement will be negative. Let's work. Let's work. I'm just gonna move this thing this side and say this is my negative 92.5. It's equals to V initial into 5. Now tell me, what do you get when you punch everything here on your calculator? I'm also putting it on my calculator on my side now.
I got negative 122.5.
Negative 110.
22.5.
Okay, let's see if I get the same answer. I got negative 122.5, ne?
Yes.
22.5. Now the aim is to find the V initial. Now we need to find the V initial. So I'm just going to move the negative 1225 this side to be positive. So this will be equals to, we're going to add the 1 to 2.5. Then we equate this to V initial into 5. Therefore, when we add this with 92.5, I get 30. So this tells me that 30 is equal to my V initial into 5. Divide both sides by 5. Divide both sides by 5. Therefore, my V initial is equal to 30 divided by 5 is 6. So this will be 6 meters per second. Now, we need to also consider giving them direction. This is 6 meters per second upwards. Okay? Mungi, the most important thing about this thing is to know that the acceleration will act downward, which will be minus 9.8. Then we have the height, the displacement will also be negative because we take up as positive. Then if you understand that part, you are good to go. You understand?
Yeah.
Okay, right. So now we know that this is what we have, and then the next question, look at what they're saying on the next question. Let's use the balloon as the reference point. We're going to use the balloon as reference point. We use the balloon as reference point. They want you to draw a sketch. I know I haven't explained the motion, the graph motion, but I'll definitely explain once when I'm answering this. A sketch graph of displacement versus time, and then they give instruction take up as positive. Okay, let's go back to the question. Let's go back to the diagram. Make sure that you understand the diagram. We have a hot air balloon that is moving up, and then once it moves up, we see that the sandbag is dropped. Okay, so now when the sandbag is dropped, okay, so the sandbag is dropped, and they say that use the balloon as the reference point, and they want you to draw a sketch of the graph of displacement versus time, and they want us to take up as positive. So this is how you draw the graph. I'm going to explain everything now. Don't worry. Okay, so when I have this like this, this will be my delta x this side. This is my delta x. Maybe I should just move this side. Okay, this is delta x, and then this will be 0, this is my 0, and then this will be my delta t in seconds. Né? I need you to pay attention. One thing we remember is that delta y is minus 92.5. So I'll just go on my graph and put my delta y. So I know that minus is somewhere here. Remember, if this is 0, going down, we're going to have negative, that 92.5 somewhere there. This is where I'm going to have the negative 92.5. Maybe I should just erase this so I can write it well. Right, negative 92.5. So now listen, they want us to use the balloon as the reference point to draw the graph of the displacement versus time, and we need to take what? We need to take up as positive. So I need to tell you something about the free falling object. If you see, look at this, the hot air balloon is moving up. We can see that it's moving up at a constant velocity. But now when something is moving up and we drop something, when we drop something, it will start moving up first before it goes down. I'm not sure if you understand that part. Please tell me if you are with me on that.
Can you please explain again? Can you please explain again?
Okay, I'm saying that if something moves up, if something is moving up and we throw something, if let's say there's someone inside this hot air balloon, then someone throws out the stone. The stone will start by moving up first before it goes down. So if this is my reference point and let's say this traveled maybe 30 meters above the ground, and then once we are on 30 meters above the ground, let's explain this down here. If this is my reference point and then let's say this is the ground, and then on the ground we travel, a hot air balloon travel 30 meters above the ground, then we throw something. Whatever that we are throwing, this stone, it won't start moving downwards. Nope, it won't move downward. It will start going up first before it goes down. It will go up and then it will reach a maximum height. Then it will come back to this reference point where we threw it. Then that's when it's going to pass and go and reach the ground. I'm not sure if you understand what I'm saying here.
I understand.
You get it?
Yes.
So now, if an object starts moving up, and this is my displacement, and they said that use the balloon as a reference point. So the reference point is 0. So this will start from 0, then it will start moving up. And we take up as positive. So remember, this side our height is positive, this side our height is negative. So if you can understand that part, everything is good. Just treat this thing as your Cartesian plane. We know that if this is 0, going up the values are positive, going down the values are negative. So this tells you that if we take up as positive, and we know that this object will start moving up, the distance of up, we don't know the distance, but what we know is that it will move up and come back to that reference point where it was thrown. Then it will continue moving down until it reaches the height of minus 92.5. You understand? So it will move until it reaches that height. So okay, so now when we say it will reach that height, how many seconds it will take to reach that height? 5 seconds. This is what we call the displacement versus time graph. trust me, if you don't understand this graph, you're going to have problems on these other graphs. You're going to have a very big problem. So this is what you need to understand so that you can be able to draw the velocity time graph. Ne? You understand, Mungi?
Yes, I understand.
Okay. The most important thing is for you to understand what is going on here. Ne? That's what is important. So now, let's work on another example. Let's see if you understand what is going on here. Ne? Okay. Okay, let's say that maybe we're going to have two cars. We can call this car 1 and car 2. But most of the time I know that you'll do vertical projectile motions, not the ones that are horizontal. So I'm just going to focus on those vertical projectile motions. Né? So I'm just going to put this guy here. Let's say this is you. Né? Yeah, you have, this is you. This is you, Mungi. And then, let's say this is your hand. Né? And then whatever that you're going to throw, if we compare this to the ground, let's say the height is 1.2, 1.2 meter. So now, Mungi, you are attempting to determine the height of the flag pole. So you have what we call the flag pole. So this is the flag pole. It will be same distance as the ground. So you are trying to determine what is the height of that flagpole. So from this is the flagpole. I'm just gonna put a flag there so that you can see that this is a flagpole now. So you are trying to determine the height. So as a science student, you suggested that you should throw a golf ball so that it reach its maximum height at the top of the flagpole. So you're going to throw something from your hand, then it's going to move up until it reaches the maximum of what? The maximum of the pole. It should be same height as that pole. Yeah. So because you are trying to determine what? The height of the flagpole. Okay. So you're going to throw something up like this, then it will come back and reach the height that it was thrown. Okay, so this is the statement. So now if the golf, let's say you throw a golf ball, if the golf ball is in the air for a total time of 1.6 seconds, let's say delta t is 1.6 seconds. You have delta t as 1.6 seconds. Now they want you to determine the height of the pole. Determine the height of the pole. How are we going to determine the height of the pole? You are trying to know what is the height of the pole. So trust me, in an exam it will come like this. They will just say something is thrown upward at the height of this, then they'll want you to calculate something. So now what you're going to do when you have it like this, you just have to write down what you have. Now you write down everything that you have. So I'm going to say, remember, everything that reach its maximum height is going to have a velocity of 0. So what I'm trying to say is that the v final here, or we can just, the final velocity here will be 0. So this tells you that once it reach its maximum, it will have a 0 velocity. Okay, we agree on that, né? And then so we know that the v initial is okay, let's just leave the v initial because we need to determine the initial velocity. I'm coming to that. And then the acceleration of this ball will be what? Let's take up as positive. So the acceleration move down will be negative 9.8. Okay, so what about the time? They said it take 1.6 seconds. So it takes determine, okay, let me go back so that I can explain what is this 1.6 now. They said that if the ball in the air for a total time of 1.6 seconds. So this tells you that to move from this point and then it reach its maximum height, then it start coming back. The ball took 1.6 seconds. So if this ball take 1.6 seconds, so to go up, delta t was half of 1.6 seconds, which is 0.8. I'm not sure if this makes sense. Tell me, do you understand why delta t is 0.8?
I understand why delta t is 0.8, but it's kind of confusing. It's a bit tricky.
Please come again.
I'm saying it's a bit tricky, but I do understand.
Yes, because they said that it spent 1.6 seconds in the air. So this tells you that going up it's 0.8 because we just have to find the height it traveled, because the same height it went up is the same height the ball took to come back. So it will come back to the same height, because now if we are trying to find the length of the pole, we have this part here at 1.2. We just have to calculate the other part. I'm not sure if you understand that part, but now okay, so now what we're going to do is that we're going to say okay, all right, so I have v initial, I have acceleration. My aim is to find my v initial. You know why I need the v initial? Because I want to use the formula that says delta x is equals to v initial delta t plus 1 over 2a delta t squared. Look at this. I don't have the initial velocity, so this tells you that we need to first start calculating the initial velocity. We need to first find the v initial. So to find the v initial, I'll use a formula that says v final is equals to v initial plus a delta t, because we need to first find the initial. Look at this. What is final velocity? We are trying to calculate the height that it traveled going up. So final velocity is 0. I'm looking for initial velocity, and then I'll have this as plus a, which is minus 9.8 delta t. Very important. Remember, we are only considering this part here. The first part that is travel, so it's going to be half of 1.6 seconds. That's a trick there, 0.8. Because The other 0.8 is the time it took to come back. So if I have this, therefore 9.8 times 0.8, this gives us an answer of what? 7.84 meters per second. So it's negative, no, so it's like saying V initial is minus 7.84 meters per second. So now I know that this is equal to 0. I can bring it this side and my initial velocity will be positive 784 meters per second. Since it's positive, it's upwards. Right, so now that I have my initial velocity, I can find what? I just need delta x, the time it took to travel. So I know this is my 7.84. I'm sorry if I'm moving fast now. So this will be 7.84 times delta t. So remember, we still use the 0.8 now because we are trying to find the time it traveled that part. So it's going to be 0.8 plus 1 over 2 into 9.8 multiplied by 0.8 squared. Right, let's separate these two guys. Right, so now when you punch this on the calculator, what is your delta x equals to? What is your delta x equals to?
Nine comma 408.
You got 9,408.
Yes.
What happened, Mungi, when you punch your calculator? What's wrong? What did you do? Because I didn't get the same answer. Or we forgot to say this is negative now. So that should be, I got 3.14. Did you get 3.14?
Yes.
Okay, but now we are looking for the height of the flag. We know that from this point here, we already know that this is 1.2, and then we calculated this part, which is 3.14. So we need to add the 2 to find the height of the flag. So to find h, the height of the flag, is equals to 3.14. We're going to add this to, what are we adding this to? That 1.2. So the answer that you get is the height, which is 4.34 meter. So the 4.3 meter is the height of the flag. Né? Are you happy with that, né?
Yes.
Okay, right. Now I'm going to close this by explaining the graphs of bouncing balls. Né? So let's say that we take a ball. Now I'm just gonna start with let's take up as positive. Let's say we take up as positive, né? And then when we take up as positive, we're going to say ball is dropped. Right, we're going to drop a ball. There's no force applied, nothing. We are just dropping the ball, né? Up as positive, and we say the ball is dropped. So we're going to drop the ball. The ball is dropped. So what do we notice? What do we know about when the ball is dropped? This tells us that the V initial is equal to 0 meters per second. Do you understand? Are you with me?
Yes.
Nice. So we are dropping a ball and then it will start moving down. So this will be my, I need, in an exam, they'll give you a scenario and they'll want you to do what? To draw a graph. So we're going to start with the velocity versus time graph. The velocity versus time graph. So this will be my graph, and then this will be time in seconds, and this will be my velocity in meters per second. Right, so now I'm going to show you how to draw the graph. So remember, we are dropping a ball, and what will happen if the ball reaches the ground? The ball will bounce. You understand when I say the ball will bounce?
Yes, I understand.
Okay, so the it starts with a velocity of 0. So we're going to start from that point. So it's going to start with a velocity of 0. Then we're going to drop the ball. Then it will start moving down. Why is this moving up? Because the more the ball goes down, it's going to increase the velocity. It will start with 0, but the more it goes down, it will increase the velocity. That's why it's going to bounce when it hits the ground. You understand?
Yes.
Okay. Okay. If you are happy with that, now let me fix this first. I just want to increase my time in seconds like this. Okay, this will be my t in seconds. So now when this is where it's going to hit the ground, then tell me what will happen when the ball hits the ground?
It will bounce.
Exactly. So when it bounces, it goes back up. You understand? It was moving down, but immediately when it bounces, it will do what? Immediately when it bounces, it will go back up. So when it goes back up, remember we said we take up as positive. No, this is wrong. This is wrong. This is for when we take down as positive. Nah? I'm very sorry. Please don't be confused. We're going to take this one is when we take down as positive, because remember, if it's moving down as positive, we're going to have it like that. So we take down as positive. So now if down is positive, this tells us that up is negative. So the moment it bounces, it's going to go up with a negative velocity, whatever velocity it bounces the ground with. So maybe we're going to start somewhere here. Remember, this is my negatives, this is my positive. It's going to start somewhere here, then it's going to go up. It will move up until it reaches the maximum height. And at the maximum height, what is the velocity? The velocity is 0. You see, if you can understand this, everything will be good. Then once it starts hitting the at the maximum, it will start moving up again. Oh, I hope you understand. So we are saying that this part it is falling because it's going down, and then this part it is rising, and then this part it is falling. So let me explain this again now. Don't worry if you don't get it. We're going to do this on our next lesson tomorrow. That's when we're going to start. So we are saying that it starts with an initial of 0. The more it goes down, the more the velocity increase. Then it's going to bounce here and it start going up. Remember we said up is negative. That's why we are starting with a negative velocity. Then it rises until it reach the maximum height. Remember, at the maximum height, it will have a velocity of 0. Then we can do this again and say, okay, once it starts falling, it's going to hit the ground, then it hits the ground, then it starts going up. The more it goes up, it has a negative velocity, then it reaches what? The maximum height where the initial velocity is 0. Then our ball will start moving up again. So what I'm trying to say is that this point here and that point is your ground. It's where the ball hit the ground. If you can understand that one, you are good. So now, let's say I'm not sure we won't have enough time to do the position time graph. We don't have enough time. Okay, fine. This is where we're gonna stop for today. Now, do you have any question based on what we've discussed today?
No.
You good?
Yes.
Okay. Thank you very much for attending. I'll see you on our next lesson. Sharp. Let me see. And Nube, I think they did answer you, negative and positive. I see Nube was asking you choose direction. Oh, wait. So when is 9.8 negative and positive? When is 9.8 negative and positive? It depends on the direction that you choose. So if you take up as positive, just know that since the acceleration always acts down, it will be negative. That's what you need to understand. Okay, thank you guys. This is where we're going to stop. Now we're doing maths, and this is grade 10 maths. This is grade 10 maths. Thank you very much for joining, as I'm going to start working with the grade 10s now.